Our next presentation is from Dr. Ron Keizer, who's a Chief Scientific Officer at InsightRx in San Francisco. Very pleased to have Ron here on a very interesting topic that I have had a lot of questions about in my own head. So his topic is precision-based dosing and the use of artificial intelligence. Just to give you a background on Ron, he's a pharmacometrician, pharmacist, and software engineer. I don't know if he has time for anything else with all of those different hats on, so that's excellent. The ability to switch over from one to the other. And he has a passion for developing tools to improve drug dosing in patients. He has held various academic and industry positions, co-authored over 50 peer-reviewed papers, and developed several commercial and open source softwares in the pharmacometrics field. He's currently the co-founder and chief scientist, as I've said, of InsightRx, and it's a San Francisco-based company developing precision dosing software for healthcare providers and the pharmaceutical industry. Welcome, Ron. I'll stop sharing my screen so that you can share yours, if that's okay. And we look forward to your presentation. Thank you.
Yeah, thank you so much for that introduction and for the invitation to speak here. So I'll be talking about precision dosing and the use of AI. Before that, I will just say, like we already said, I work for a company called InsightRx. We make a precision dosing software. I think you must have been living under a rock if you haven't heard in the past half year about AI. It's basically everywhere. It's really taking over the world, at least if you believe the headlines. So there's a lot going on, and a lot was about the large language models, ChatGPT and things like that. And it will affect a lot in our society and also in medicine, I think, in the coming years. But there's a lot of questions about how accurate it is, because it's actually making up a lot of stuff at the same time being very confident about it. So that's of course a very dangerous combination. And besides that, there's also a lot of legal aspects that we still need to work through, like IP and regulatory, privacy, ethical, etc. So there's a lot that we still need to figure out. But in broad strokes, AI is coming for medicine as well, and it's going to be exciting to see how that panned out. But right now, I want to focus a bit more narrow on precision dosing, and also we need to define a bit more what at least in this talk I'm going to mean with artificial intelligence, because here I'm going to define it as really as sort of two branches. There's really the machine learning approaches, where you learn everything from your data. You don't have a structural model in place. And that's the other approach that's perhaps a little bit more known to us, at least in the pharmacometrics field, is the really structural models. Of course, these are also trained on data, but there's a structure in place that sort of holds everything together. The machine learning approach, you can then further divide in generative machine learning or artificial intelligence, and predictive machine learning. And generative is really what all the excitement in the past half year has been about, especially with the advent of ChatGPT and things like that. But in this talk, I really want to talk more about predictive machine learning models. For example, machine learning models that are built to predict neutropenia or renal failure, things like that. And of course, I will also talk a bit about PK models. What do I mean with precision dosing? In this talk, I'm really only going to focus on clinical use. I'm not going to talk about how it's going to affect drug development, for example. And in clinical use, the precision dosing, what we do is really mostly around antibiotics, transplantation medicine, oncology, and a few other disease areas. But that's sort of the scope of this talk. But there's a lot more to it to explore, of course. I selected a few examples of AI in the precision dosing field. But before I'm going to move into that, I want to sort of share the state of the art of what's been happening in the past, let's say, 5 years or so in the precision dosing field, without even looking at artificial intelligence, because I think that's important to set the stage. And one of the pillars, I think, nowadays of any precision dosing application is really to have your application integrated with the hospital system. So this is a screenshot of the application that we built, and you can see it's really integrated with sort of the blue. The blue area is really the hospital system, and the other area is our application. And it's really integrated, and that's super important. To have an efficient workflow as a clinician, to reduce the number of errors that you make, and yeah, that's really helped the field, I think. Another pillar of precision dosing, of course, that it's model based. I think most, if not all, of the precision dosing applications these days are based on models, and so the bread and butter of these applications is really PK models that really describes the concentration of drugs in the body. But there's also the possibility to do it using PK/PD models that describe the pharmacodynamics as well. And here's just an example of a neutropenia model, so describing the future neutrophil counts in a patient based on the exposure to a chemotherapy drug. And we are actually working on an application to use this as well at the point of care. And lastly, what we've seen as well develop in the past few years is actually machine learning models that predict PK parameters. And I think the first example of that was by a group from Limoges, by Wayar et al. And they show that you can train a machine learning model to predict, for example, the area under the curve based on the patient covariates and just 2 or 3 samples, and to get actually a comparable accuracy compared to more a classic approach, or even slightly better. And yeah, I think this will develop further, and it will come. We will see more applications of this. And then the third pillar, I think, is also very important, and is also linked to artificial intelligence, is that we need to learn from our data that we collect. And we've been advocating this approach for a few years now. And at first we implemented this manually, but we now have this also in a fully automated approach, where we actually learn from the data that we collect. And that's really to move towards a really integrated approach, where the hospital system is integrated with the clinical decision support tool, and where the clinicians actually curate your data, because of course to give a precision to give a dose advice, you need to make sure that the extracted data is correct, and that's what the clinician is already doing. That's very important, because if you want to learn from data in your data lake, you need to have clean data. Once you have the data lake, you can then build new models or update, retrain your existing models. You can evaluate how well your clinical decision support tool is doing in clinical practice, and yeah, basically you can build a whole dashboard for that platform. And all of these things, the things you learn from these applications, you can then feed back into the clinical decision support tool itself, the precision dosing tool, to make your models better, or your algorithms better. So this is already happening. This is sort of the what I think a modern precision dosing application should look like. But what I want to highlight now is sort of a few examples from the really latest developments in this field, and then focus more on machine learning as well. But before I go into these examples, I want to sort of highlight the workflow in a clinic for precision dosing. And it's really that you have the clinical data for a patient. And then based on the data, you select a model. Of course, you need to select the model for the specific drug, but also based on maybe renal function or the age group of the patient. And then based on that model, you do a fit and based on the fit, you do a prediction, and then using that, you can then get an advice for that patient for the actual dose. And how can machine learning help here? Well, I think it can help in basically every stage of this whole process. And the first stage, of course, is to select the model or models that should be used. Machine learning can help there, and I will have an example of that. It can actually help improve our models, improve the predictions from existing models, and I'll show an example of that. And then lastly, it can also help design the next regimen for the patient. So about model selection, this is a paper that came out a few weeks ago. So this is very recent data. In this paper, they show that you can use machine learning in sort of the realm of model averaging. And model averaging is a technique that if you're not happy with a single model, you can actually use more than one PK model to fit your data and to predict out into the future. And then the weights that you use in the model averaging, because you want to use perhaps the weight for one model more than a different model, is always based on the response that you get. So you weigh based on the observations that you collect. But the disadvantage of that has always been that you have to wait to actually get a first TDM level in before you can do that weighting. And if you don't have that first TDM level, you can only do sort of a naive weighting. And this machine learning paper describes an approach where you actually you actually train a machine learning model to learn that from the covariates itself. It sort of matches it to the population it was actually developed on. So this is this I think is a very nice example of how machine learning can help in this process. And we'll see how this will actually work in clinical practice. A second example is really about improving the fit or improving the predictions from our model. And this is something that we developed ourselves. And this is really about the way that you do a fit. And when you fit data for a patient, you of course have the population predictions where you only look at the covariates for the patient, but then if you do a fit to let's say the first observation that you make for this patient, you actually, what you usually do is a Bayesian fit where you weigh the observed data versus the model predicted data, but you're not going to listen to only the data and not only the model, but you more or less end up in the middle somewhat. And it looks like a bad fit, but it's just to protect against noise from the data. But what you could do is actually say, we're going to listen for this patient. I actually don't really like this model, so I'm going to listen more to the data. And that approach is called flattened priors. And then you listen much more to the data and not so much to the model. But the question now is, what prediction is actually better? In some cases, we see that it is actually better to do that, to listen more to the data. But in other cases, it was actually just noise. And it would have been better to actually listen more to the model. So, so how do we decide what approach to use in clinical practice? Well, we thought maybe we can actually train a machine learning model to figure out which approach is better for the individual patient. So that's what we did. And to cut a long story short, we found that machine learning model actually could improve the predictive ability of our models. So that's just existing PK models by around 15%, sort of depending on the situation and depending on the model. And we also looked, because the model was fairly complex and we want to implement it in clinical practice. So we made a more a simple model, and even that minimal model was able to improve the accuracy by almost the same amount. So then looking at the third example that I wanted to highlight is really going from the fit for a specific patient to an advice. And these authors, they showed last year that you can also do that by using a slightly different approach. Is using reinforcement learning. It's also a machine learning method. And there they show that, okay, for the initial dose, when you have a nomogram, you can use that. So based on body weight, for example, and here it's also based on the IgG levels. So you have an initial dose in a nomogram, but over the course of therapy, you can actually retrain those nomograms to sort of design the regimen for the patient on the fly. And this is a really nice approach. And yeah, we just have to see how clinically feasible this is, but it's really interesting to see that an approach from a different field can really be useful in pharmacometrics as well. But there's of course a caveat. I do also see a lot of AI research at meetings or at in articles, and I must also say that a few of those are really not not really improvements over what we've been doing over the last few years. Because they just redo what has already been done. So I think that's great as an experiment, but we really have to keep in mind, is this really something new, machine learning applied to this field, or is it something just to show that you can also do it using machine learning, but it's not actually improving the field? So that's something you have to keep in mind. And then the last thing I think you have to keep in mind, which is even more important, that it's all about the implementation in precision dosing. Because if these models, even the most fancy models, if you can't implement them at the point of care, then it's all then it's not going to be useful. So there's a lot of reasons why a machine learning model or any other model can actually fail to be implemented. And this is a very nice paper that shows sort of a list of these patients, and I actually highlighted a few that are very specific to machine learning. So with that, I'm going to end with this summary slide. I think AI will change the world, but we have to be careful of hype. AI and machine learning will come to precision dosing, but yeah, don't expect dramatic results. It will come, it will be incremental. Implementation matters a lot, so really focus on that. And my last note is really that it's a super exciting space, and I think it's really useful to educate yourself on this field, because it will become more and more important. Thank you for your attention.
Ron, that was an excellent presentation. We're very, very happy that you had a chance to go through and just touch upon some of the things that AI and machine learning may be able to approach in pharmacometrics, and of course, translate that to hopefully at the bedside where we can use it to help with dosing difficult to treat patients. So really appreciative. And I'm sure that'll generate lots of questions. I have a few in my head, but I'll save them for the Q&A at the end of this this webinar session.